Hi, I am Noah Dubin, Senior Program Manager for Innovation and Partnerships at New York City DOT. Our mission is to provide for the safe, equitable, and sustainable movement of people and goods and to create public spaces that strengthen New York City's communities. And thanks a lot to Pitchfest for having us and for letting my agency submit such an egregious number of entries this year. um, so I'll be quick. We're responsible for the planning, maintenance, and expansion of the city streets, highways, and public plazas, its bridges, its signalized intersections, and of course the Staten Island Ferry. We've got some extremely exciting initiatives on the horizon, including some street redesigns, the expansion of our bike network, the development of some key bus lanes, and the establishment of an office of curb management. And I think all the pitches you're going to hear about today are reflective of these key priorities and the incredible work that this agency does. So I will turn it over to my first coworker. Thanks.
Cool. Awesome. Hi, guys. My name is Taylor Takahashi. I'm from the ferries team at DOT. And the pitch we have for you today is creating an easy pass for marine vessels. So DOT has a few ferry landings that serve various private ferry operators where vessels of different sizes and shapes can dock. Currently, our landings rely on hardwired hand controllers to operate bow loading ramps, which are pinch points, subjecting mariners to physical hazards and frequent points of failure due to harsh environmental conditions or user errors. Early this summer, we'll see over 2,000 touches per week, and as we move into peak season, this number will only go up. Blue Highways has also launched, which brings cargo into the city's existing ferry landings. That's over 2,000 opportunities for the controllers to get damaged, and these recurrent breakdowns take vital berths out of service. Our proposal solves this by developing a wireless system to operate the ramps remotely from the vessels, paired with an automated, easy pass style system for seamless landing fee collection. This modernization directly supports city priorities by drastically reducing repair costs and berth downtimes, ensuring accurate revenue collection, and creating a significantly safer working environment for our maritime industry partners. We would share with our researcher ferry schedules, landing fee structures, and automated identification system data on vessels with approved ferry licenses. And we look forward to working with you.
Good afternoon, everyone. My name is David Yep, and I work as the data analytics lead in DOT's public engagement program within the Transportation Planning and Management Department. So very briefly on what our team does. So we serve as the primary public engagement wing of the agency as it relates to transportation planning. We conduct hyper-local outreach by meeting New Yorkers where they are. So places like bus stops, libraries, senior centers, community events, and other neighborhood destinations. And we do this so residents can provide feedback directly to the agency and help shape our street improvement design process. A critical part of our mission is really reaching communities that are often underrepresented in traditional planning processes. So this proposal looks at bus priority projects and their connection to local businesses. So as many of you already know, DOT has made significant investments over the years in bus lanes, signal priority, and other treatments to make buses faster and more reliable. At the same time, we also hear a lot of pushback from businesses, particularly about that these types of projects are hurtful and may be hurting their business model. And we know that this is not necessarily true, but I think there's an opportunity in developing a stronger way to measure how these investments are actually supporting commercial corridors and the businesses along them. And this idea builds on two things: our own public engagement work on Flatbush Avenue and other bus corridors, and also citing a 2024 Flatbush Avenue report from the Pratt Center and the Riders Alliance. So both efforts revealed similar insights about bus riders. They are not just commuting to places, they are using these corridors to access food, access businesses, services, everyday destinations, right? And the report found that the top reported trip purpose for survey riders was for dining, shopping, entertainment. And 85% also said that they would shop or dine more often if buses were more reliable. So our goal is to build a reusable framework, essentially, that measures rider spending, a few things like business access, time savings, and equity outcomes. And we're looking for a research partner to help really turn this into a defensible methodology at DOT, so that we can use it for future bus priority projects. And secondly, and to support stronger talking points for City Hall, elected officials, business improvement districts or bids, and other external stakeholders. Thank you so much.
Hello, everyone. My name is Leah Franklin, and I'm a policy analyst in the Sustainable Delivery Unit at NYC DOT. Our team is tasked with programming, policy, and most importantly for this crowd, research related to on-demand delivery work in New York City. As daily users of New York City streets, many of you are already aware that on-demand delivery, particularly of prepared food, has expanded greatly since 2020, with more than 80,000 delivery workers using New York City's streets. While this work is mixed mode, many of these workers use micromobility, most frequently e-bikes and mopeds. Users of these modes in particular have turned to the city's streetscape as a place to rest, park their devices, eat, wait for future orders, or just create community. DOT is interested in understanding how delivery workers use these spaces that were not originally designed for those aforementioned purposes, and the opportunities and challenges that arise due to this use. While DOT has piloted different streetscape interventions with delivery workers in mind, such as delivery worker rest areas or expanded bike parking in front of popular restaurants, there has been no substantive analysis of how to comprehensively plan for the workforce. Our two research questions are as following. 1, to what extent did different public space typologies influence delivery workers' comfort, perceived safety, wellness, and operational efficiency? And 2, what trade-offs or co-benefits emerge for other street users? Through field observations, surveys, and quantitative analysis, we aim to answer these questions and perhaps generate further questions for future analysis. If you are interested in this intersection of transportation, labor, and street design and want to holistically investigate how this emerging industry is impacting our streetscape, we would love to collaborate. In exchange, we hope to provide incomparable expertise and connections in the delivery worker space, access to our sites, and collaboration with our agency's internal work. Thank you all for your time, and we hope to continue the conversation.
Hi, everybody. Jonathan Hawkins, Director of the Streets Plan for DOT, which is our citywide streets master plan. It's a really exciting time to be doing this work right now, as you can imagine. Capital street redesign projects in New York City are very expensive and they're very time consuming. So as a result, most street redesigns for things like bike lanes, bus lanes, public space are built in-house by DOT. We design them and we implement them using our own staff and contractors. And we built a very impressive program. Much of what you see when you walk around the city came from our in-house work. We're doing a ton of projects, more than 100 a year, probably going to be a lot more now. But what we can do in-house is somewhat limited because of issues like drainage profiles, utilities, a lot of things that historically to address, we've had to reconstruct the entire street at great costs and time. So we want to do more in-house to build projects that feel more robust, that feel like they've been there forever, and that require less ongoing maintenance. We've had some very recent successes. We're doing a lot more with concrete, but we want to do more. So think less painted spaces, less delineators, more concrete, feeling more robust. So we want to know, this is a very straightforward and simple topic, but we really would like to get into the nitty gritty. What are other cities that are leading this type of work, particularly internationally? How are they doing these projects and what can we learn from them? What are the timelines like? To what extent are they using in-house resources versus contractors? What kind of construction techniques and materials? What kind of procurement rules do they have to work around, et cetera? We really want to get into the weeds every step of the process. We talk a lot with our North American peers through organizations like NACTO, but we have somewhat of a less deep understanding of cities abroad. We sort of see the results, but we don't really know how exactly they're doing it and what is it that we might be able to adopt from them. So we will offer our staff to anyone who's interested, both on the planning and engineering side, but also the construction side to understand how our process works. But we would love to get some help in learning what are we not doing that we can start doing. So looking forward to hopefully talking to some of you. Thank you.
Good afternoon, everyone. My name is Katrina Carey, and I'm the Freight Efficiency Program Lead at within the Freight Mobility Unit at the Department of Transportation. Freight Mobility is committed to advancing transformative policies and programs to enhance the safety, efficiency, and sustainability of goods movement, mitigating the adverse effects of traffic on infrastructure and communities. With that in mind, DOT is currently in the early research phase of exploring a potential low-emission delivery zone pilot aimed at reducing the environmental and quality life impacts of last-mile deliveries across the city. Our goal is to identify scalable, replicable strategies that can improve air quality, reduce congestion, and support a safer, more sustainable freight movement. As we explore the potential approach for the pilot program, we're looking for support in the development of a tool or a set of tools, such as an interactive dashboard, scenario planning model, or map-based application that can assess feasibility of low-emission delivery zone implementation, and that measures the theoretical environmental, operational, and mobility effects of low-emission delivery zones. Through this collaboration, we hope to answer two key questions. How can NYC maximize the benefits of low-emission delivery zones, and what combination of tools and strategies would be the most effective? We're especially interested in collaborators with expertise in geographic and spatial data analysis, data visualization, transportation planning, freight systems, and environmental justice. We're excited about the opportunity to work with innovative partners and shape a cleaner, safer, and more efficient future for freight deliveries in New York City. Thank you.
Good afternoon. My name is Jascha Pfefferholz. I am an economist at the Policy Unity at DOT. We are presenting Valuing the Societal Benefits of New York City Street Projects. DOT makes decisions about investments on street capital projects every year. For example, where to install protected bike lanes, widening sidewalks, or even new open streets. We at the Policy Unit conduct benefit cost analysis to understand what are the projects that provide the highest value and to prioritize these projects. The challenge is that we don't know many of these values because there's no market values. So for example, how much people value trees or how much people value being able to cross the street safely. We've been doing stated preferences since 2019 to understand these values. Stated preferences are surveys where we ask directly to New Yorkers how much are they willing to pay for these attributes. And the results are very incredible. We found out that actually New Yorkers value trees significantly, as well as medians with greeneries. We want to continue doing this work. So we want to be able to measure different types of bike lanes, different types of crosswalks, value open streets. So if you are an expert in discrete choice modeling or stated preferences or economic valuation, please come talk to us. We have agency time, our expertise. We can provide data and previous methodology and connections with city agency. And we think this is a good opportunity to improve New Yorkers' quality of life through rigorous economic analysis. Thank you.
Hi, everyone. My name is Katrina Quadra, and I'm with the Analytics Performance and Management team. And we're seeking a computer vision platform to support our asset digitization efforts. DOT manages a vast portfolio of physical assets across the city. Think signage, infrastructure, street furniture, and more. And while we have access to regular cross-city imagery, what we lack is a systematic, automated approach to inventory and classify what's in those images. Our current digitization efforts are either manual or outsourced, and neither scales or gives us full ownership of the process. What we're looking for is a comprehensive platform that handles the whole workflow: imagery ingestion, annotation, model training, and deployment in a nice UI. It needs to be a repeatable, maintainable pipeline that our team can use over and over again. The goal is to bring this work entirely in-house, starting with a prototype that's focused on a single asset class. What we'll provide for you is imagery, existing asset data, a dedicated computing environment, and staff support. We're looking for a partner with expertise in computer vision, ML infrastructure, and user-friendly design in order to support non-specialist teams. Thank you so much. And if this seems like something you might be interested in, please let me know.
Hi, good afternoon, everyone. My name is Carl Sundstrom, Chief of Cycling and Micromobility at DOT. And our problem statement is really on mode shift and mode choice. So, I think in general, New York City is, quite a dense place, but many trips that could be done by cycling and walking are still done by car. And so what we really want to understand is, what are those barriers to cycling and walking, and which fixes can sort of be done to improve that? So we really want to focus at the neighborhood scale. So there's sort of a lack of great data that we have at that scale. So we generally have a better understanding sort of at the citywide level, but what does it look like at the neighborhood scale? And so we're proposing to use Astoria, Queens as a neighborhood for this problem statement to really understand. Okay, so how are people choosing to make their trips, and what are the reasons that they're not walking or biking? And so can we take that information and can we quantify that to really measure the impact on that mode choice, and sort of assess and prioritize improvements to create a scalable framework that could be used in neighborhoods across the city. I think we're quite open to what that approach may be. We just really want to understand, what these barriers may be, and how we can make cycling and walking more attractive to New Yorkers at the neighborhood scale. Thank you.
There it is.
Hello, everyone. Good afternoon. I'm Catherine Ponte. I'm our freight strategy lead with our freight mobility unit here at New York City DOT, and I will be presenting on measuring the impact of last mile distribution hubs. So this proposal is really to look for support for a novel set of policies and programs that we've been actively pursuing in terms of reducing our truck VMT. As many of you know, we have a lot of issues with a lot of trucks on our streets due to our rise in e-commerce and delivery. And so because of that, we've looked at strategies such as these small-scale last-mile distribution hubs or micro-hubs to transfer these goods, to provide safe spaces to transfer these goods to sustainable, smaller last-mile modes. This activity is happening both within our current ongoing pilot as well as programs such as our Blue Highways and Cargo Bike program. And what we're seeking, and also beyond our pilot, kind of informally and in private sector across the city. So what we would love is for research assistance in really capturing the data of how this methodology, how this new strategy for freight delivery is impacting our city in terms of these benefits that we're hoping that it's providing, and we'd love to quantify that, related to safety, economics, and our environmental sustainability. So this is a great opportunity to be part of very cutting-edge research on a new approach to freight delivery that we're just beginning to understand the ramifications of. And so as researchers, you would be assisting us and to create some initial visualizations that will inform the policies and the future of how we approach this strategy and tool for managing freight transportation within our city. So we really hope that we can work with someone who can create some really great data visualization tools and data collection strategies that really capture the broad impacts of this new activity and like help set us up for future policy and program improvements in the future. So thank you very much.
Okay.
Hi, everyone. I'm Dee Nelson, Director of Policy and Design Guidance. For our geometric design unit, I think the most appealing thing about our pitch is that it's an incredibly discrete research question. Very appealing. It's very straightforward how to measure and come up with a conclusion. So basically, where we have slight left, slight right intersections throughout the city, they're usually off of arterials. You can think about the roadways that line freeways, like the Bruckner Boulevard or Meeker in Brooklyn along the BQE, where you have slight intersections. They basically function instead of like an urban street intersection, almost like an off-ramp, allowing individuals to make pretty high-speed turns where we typically have a crosswalk. A lot of these are uncontrolled, like T-away intersections. And so basically the way that DOT usually handles these intersections, because of their high speed and the prevalence of a crossing, a pedestrian crossing without intersection control, is that we try to adjust the geometry, usually with paint and plastic posts, to make it where it's more of a right-angled turn by retrofitting kind of within the existing right-of-way, that right angle. And the problem that occurs with that, and the thing that we're really wanting to do this research to assess is to what degree is this a problem, is that when we have to accommodate emergency vehicles like FDNY fire trucks, maintenance vehicles like DSNY garbage collection, those larger vehicles, we have to widen the treatment to fit those vehicles through. And at a certain point, logic dictates that the efficacy of this would go down because smaller vehicles would just be able to still make the slight left or slight right instead of kind of weaving through the intersection. So that's kind of the problem statement. So basically what we'd be looking for is we need to sort of understand the yielding behavior. Are these vehicles stopping to pedestrians when they're in the crosswalk? What speed are vehicles taking through these based off of the size of the vehicle, especially? So is a passenger car still speeding, but larger vehicles are slowing down? That would be an important thing to understand. And then exactly what traveled path are they taking through? So sort of mapping out what those, the footprint of the vehicle through this intersection treatment really is, so that we can develop either alternatives to the design or some sort of morphology set of parameters by which we adjust it. You know, maybe it's not a 90-degree turn, but some intermediate value between the existing angle and 90 degrees. And what are the parameters that could inform that? But really, more than anything, we need that data of the speed, yielding behavior, and the traveled path. We have a database of where these locations are. We can also provide ones that would be before and after for projects that are currently in implementation or would be in implementation during the data collection period. And then a whole host of aerial and street view imagery and LiDAR data to be able to take all the measurements you could possibly need. What we really need from somebody is to be able to probably do time lapse, to measure or some sort of remote sensing to figure out what those paths are, those speeds, and then to quantify the yielding behavior or lack thereof. Cool. It's a very exciting project that could really improve safety in a location that causes a lot of deaths and serious injuries in the city. Thank you.
Hi, everyone. Right. Okay. Hi, everyone. My name is Elia Kasim. I am a senior data analyst with the Freight Mobility team. And today we are proposing to develop a computer vision tool for curbside freight analytics. And this project will aim on exploring how computer vision and machine learning can help us better understand curbside freight activities within the city. Today, most of freight data collection relies on manual observation and short-term field studies, making it difficult to continuously measure curb operation at scale. Our goal is to develop a scalable Python pipeline that processes existing video feeds and automatically identify freight-related activities, including trucks, vans, cargo bikes, loading events, curb occupancy, and dwelling time. The key questions are how can we transform historical video data into continuous structured freight analytical that transport better curb management and can help us with the policy decision making. More specifically, where are the loading activities are centered? How are commercial vehicle occupying curb space? How are cargo bikes and micro hub changing freight pattern? How can cities measure curb efficiency more consistently over time? By converting videos into structural data, this project could help establish a baseline freight activities pattern and support future planning. What we will provide are the historical video recording, technical guidance, and operational expertise. We are looking for research partner with expertise in computer vision, machine learning, GIS, and urban freight systems to help develop and scale this solution. We look forward to working with you, and thank you.
Good afternoon, everybody. Good afternoon. Thank you very much. So I just wanted to thank everybody for coming out on such a beautiful sunny day. I did. And quick show of hands, how many people got a chance to walk around on the pavement and asphalt the last 3 days? Show of hands. Great. How many of you had broken air conditioners? Oh, not just me. Great. Okay. So obviously, we were able to get a glimpse into how New York City's urban heat island affects all of us. Temperatures are rising. They can rise anywhere between 1 to 7 degrees, in some cases, all the way up to 15 degrees of real feel. And it impacts underserved neighborhoods the most. That's where we find some of our highest heat vulnerability indices, and where we also find the least number of tree cover or even building shade. So this drives higher rates of heat-related illnesses, as well as poor air quality and environmental equity. How many of us saw all those air quality alerts on our phones? See? So imagine if it wasn't May. Imagine if it was July 24th, or heaven forbid, June 24th of last year. That was awful, right? So DOT is already trying to address this. We're trying to do things with cool streets and cool pavements. Parks is doing things with street trees, trying to redesign streetscapes, but these are slow to scale solutions. I mean, imagine reconstructing the street and how long that takes. So, and there's limited things that we can do in a dense environment that already has so much in it. So my idea is green cocoons. You may have seen something similar like this in a Medium article. Well, I'm taking it and I'm running with it. And I would like to know if we can build some sort of modular canopy. Pergola, you might want to say, but technically gantries, where vegetation can then grow, where we can install sun sails to shade the area and reduce heat exposure and improve pedestrian comfort. Perhaps we can also add fans and misters that are solar powered. All of these ideas are great. They're all springing from my brain. But ideally, what I would like to get out of it is a pilot-ready framework and a way to measure KPI. So I need pre and post temperature, air quality data, along with the scalable deployment model. So what we can give you is data and sites, as well as staff coordination. You get to work with me, and aren't I awesome? Right. Okay. See how much you're laughing? Imagine working with me all the time, right? What we're looking for is some sort of urban client science designer, environmental engineer, landscape architect to really get this project started. Ideally, we would like to at least have an idea for a pilot, possibly even get something off the ground, who knows, but let's get started with this, and then let's see where we go from there. Thank you very much for listening to me. Looking forward to working with you.
Okay. Good afternoon, everyone. I'm Susan Lee from Bike Share and the Shared Mobility Units. And our unit oversees the City Bike program, which is the largest bike share program in North America, like with over 2,200 stations. And like one of the big, like the operational hurdle for this program is the managing station relocations. As we all know, the cities, the roads are always busy, and then this street construction constantly force us to move our station to the new location and breaking our vital network connections. And yes, so and then currently our planner uses the static guidelines and the intuition to identify alternative the site. But this lack of the optimization lead to the system inefficiency, directly affecting the system ridership and then the rider behaviors. So today we are proposing a data-driven approach to solve these issues. And the central research question is, can a predictive network model forecasting localized the ridership and then rebalancing needs, the trigger by moving a station? And we want to build this model that simulated this network shift before it happens. So or every that will ensure or every relocation activities that preserve our network integrity and also support the city's sustainable mobility goals. So, and then the ultimate program deliverable is a station impact simulator prototype to quantify the ridership delta under various special the constraints. And then to achieve this, we will provide the full access to the City Bike data, which include the trip data and also all historical station status data, and also the GPS, the trace data from our e-bike trips. And then this is where your expertise come in. So we are looking for researchers or civic tech partners who specialize in the graphic theory, network topology, or predictive modeling. And yes, and then we are looking forward to collaborate. And then thank you for listening.
Good afternoon. My name is David Stein. I'm an executive director in the parking division at DOT. DOT is charged with the management, maintenance, and operation of over 14,000 parking meters and 400,000 streetlights and signal poles. So the scale we're talking about is immense. This is critical infrastructure in the city with parking meters. It's responsible for $250 million of revenue. And while the city is moving toward asset-light solutions like mobile payment, having a parking meter is critical for regulating the curb. Same thing with streetlights, providing lighting, ensuring safety, visibility, and management of the streets. Because these are essentially pieces of steel mounted on the street, typically in cement and concrete, they are exposed to the elements. I try to as politely put what it is exposed to. So moisture, obviously, if any of you saw the flooding yesterday, we get a lot of flooding, we get snow, we get a lot of water infiltration in and around this infrastructure. And there's also a lot of chemical exposure. So over time, these create structural integrity issues, corrosion, and thickness loss. Worst case scenario is what you see here. A meter corrodes, falls over, poses not only an issue for public safety or someone using it, but also this is a critical piece of agency infrastructure. It has money, it has computers and other things within it. The city is looking at a multi-pronged approach. First, we're looking for assistance in understanding and mitigating the contributing factors which are leading to the corrosion. So we have some ideas and some experience, but we're looking for assistance in better understanding what is contributing to this. On the meter side, most of this infrastructure is about 10 to 14 years old. And really, if I'm just jumping to the outcomes, we're looking to expand or extend the useful life of these critical assets. When the city tries to replace something, again, when I talk about scale, 14,000, 15,000, any growth is a huge amount of, a huge endeavor. So expanding the useful life of this is a critical component of this exercise. And we're also looking at help in mitigating strategies. So the question that we have is, how can DOT better inspect and model structural degradation in a minimally intrusive way? So is there any processes or procedures that someone doesn't have to open up a meter, or we can model how that happens over time? And then also, given New York City's urban environment, what opportunities are there to stem or slow corrosion? So DOT can offer our experience, technical and operational data, inspection records, specifications related to installation and how these meters and street poles are installed. And then also our vendors are very much open to this. One of the things is most of the vendors, at least on the parking side, are changing the type of steel they're using. So we are looking at a research partner with a background in structural engineering and materials testing, as well as also asset management best practices. Thank you.